So remember we had two properties of arteries. We had elasticity and contractility, and we said we were going to talk about two different types of arteries, elastic arteries and muscular arteries. So elastic arteries are on the left, muscular arteries are on the right. Elastic arteries are also called conducting arteries. These are the large arteries. They have a larger percentage of elastic fibers and less smooth muscle. That composition of elasticity, or the elastic fibers, are going to allow them to have more stretch. They're going to be able to receive blood under higher pressures. They're going to be able to propel that blood onward. And they actually are able to function as a pressure reservoir. So they're able to handle larger volume, higher pressures, and they're called the conducting arteries. Muscular arteries are medium in size. They have more muscle, more smooth muscle in them than they have elastic fibers, so that tunica media actually has a more prominent muscular layer than an elastic fiber layer. These guys are capable of greater vasoconstriction, so constriction and dilation. So constriction and dilation of that vessel, so that's vasoconstriction and vasodilation. And what that does is it allows these vessels to adjust the flow rate. Because they have more muscle, they can adjust the flow rate. And the muscular arteries are also called the distributing arteries. So you want to know conducting versus distributing. You want to know who has more elastic fibers, who has more smooth muscle. You want to know who acts as a pressure reservoir, has the ability to deal with that pressure, who has more ability to vasoconstrict or vasodilate and thereby influence the flow rate. As we said initially in our first video, smaller versions of arteries are called arterioles. What arterioles do is they regulate the blood flow from those high pressure vessels, the arteries, into the capillaries. The capillaries being very tiny, one cell thick, very small diameter areas of exchange. So arterioles are going to work through vasoconstriction and vasodilation. And what they're going to do in using those two mechanisms is they're going to alter the arterial blood flow. Vasomotion, another vocab word for you. Vasomotion is this intermittent contraction and relaxation of the sphincters, and what's going to happen is we're going to allow capillary bed filling. And that's going to happen about 5 to 10 times per minute. So over here we have this arteriole, okay, coming off an artery. We have arterial blood in here. We have oxygenated blood in here. Just to orient you, you have an endothelium. You have some smooth muscle out here. You have a main vessel that's going to go through the center of this capillary called a metarteriole, and I believe that's our next topic of conversation on the next slide. But you have this main vessel going down here to the venous side of the capillary, and that main vessel is called the metarteriole. And then branching off of this metarteriole are all of these small capillary vessels. Remember, in and surrounding all of these capillary vessels are cells. And what we have at the junction to each of these is called a precapillary sphincter. And when it's relaxed, the capillary bed is open. And when it's closed, then we don't get blood flow through there. So what we can actually do is we can alter the flow of blood through this capillary by which capillary sphincters are open or not open. There's a post-capillary venue over here. We'll talk about that in a moment. But what we're going to get is we're going to get this intermittent contraction and relaxation of these sphincters, as I said, about every 5 to 10 times per minute. And what that's going to do is it's going to allow filling of the capillary and outflow, filling of the capillary and outflow. We have, as I mentioned, this main vessel that's going to connect the arteriole with the venule, and that is called a metarteriole. Metarterioles are important in that they allow us to bypass a capillary bed entirely. So we can close off the precapillary sphincters. Blood is going to flow directly from the arteriole through the metarteriole out to the muscular venule and move right through without having any issue in the capillary bed. Vasomotion, remember vasomotion we mentioned in the last slide. Vasomotion is the intermittent contraction and relaxation of the precapillary sphincters. That happens about 5 to 10 times per minute. So what the capillaries do is they form a microcirculation, if you will. So they connect arterioles to venules. Every cell in the body, I think we've mentioned this before in class, but every cell in the body is near a capillary. There'll be more capillaries in tissues that are very active, muscle, brain, kidneys, liver, those sorts of organs, the spleen. What we're going to do, what's physically going to happen at those capillaries is we're going to have an exchange of nutrients and wastes. So those nutrients are going to leave the bloodstream, cross the interstitial fluid so that they can enter the cells, and in the reverse direction, wastes are going to leave the cells, enter into the interstitial fluid so that they can then be picked up by the vessels. Capillary walls are thin. They're composed of only a single layer of cells and a basement membrane, so there's not a whole lot to them as far as anatomy goes. You'll recall that we said that single layer of cells was the exact same tissue type and was connected with all the way through the vasculature of the body and all the way back to lining the chambers of the heart. And if you're stretching your brain, trying to remember what that's called, it's called endothelium. So what we have here at this capillary is we have this layer of endothelium surrounded by a basement membrane, and that is all that we have comprising our capillary. Okay, let's take a break here. We'll pick up the next video looking at capillary types, and we'll go from there.